Sample problem 8.7. Draw the Lewis structure for carbon disulfide CS2. Okay, so we're going to follow the strategy laid out in the lecture. So CS2, carbon disulfide. So we first identify the central atom. There's only one carbon and there's two sulfurs. So we put the carbon at the center. We then surround it with one bond, a single bond, with two sulfurs. Generally, if there's two of them, you put them on opposite sides. If there's three of them, you put two on the sides, one on the top. If there's four of them, you put two on the sides and one on the top and one on the bottom, something like that. Okay? So there's CS2. Now we start counting. Carbon is in group 4A, so that means it has 4 valence electrons. Sulfur is in group 6A, which means it has 6 electrons. So 1 times 4 plus 2 times 6, and that gives us 16 electrons. Remember, there's 2 sulfurs, so it's 2 times 6. We've already drawn in 2 bonds, so we've used 4 electrons. That gives us 12. And we have a choice. We could put 6 on either side. In fact, that's what I'm going to do. I'm going to put 3 lone pairs on each surrounding atom to get them up to 8. So unless it's hydrogen as a surrounding atom, try to get the surrounding atoms up to 8. That was 12 electrons. So that's 0. Okay? So let's remind ourselves. Each lone pair is 2 electrons. So the sulfur here has 3 lone pairs. That's 6. And we already accounted for 2 more. That's 8. So we've used 8 out of these 16. 2, 4, 6, plus another 2 is 8. We've accounted for another 8 in these 16. And now it's all done. The problem here is that carbon only has 4 electrons. That's no good. We want carbon to have 8. So generally, what you do is you push a pair from one of the surrounding atoms, and I use the curved arrow notation to represent that, so that the lone pair, oops, let me erase that lone pair, so that the lone pair now becomes a second bond to the central atom. Okay? That gives the central atom another pair of electrons. So now that pair is shared. Remember, a shared pair of electrons is counted by each atom in the bond. Okay? Now, the carbon still only has 6. So we actually have a choice. In a sense, we could push another pair from the sulfur on the left, or we could push a pair from the sulfur on the right. Usually what happens, the most stable structures are ones in which if you have surrounding atoms, more than one, well, you've got to have more than one surrounding atom, the surrounding atoms will share the same number of electrons. Meaning, if you have 2 sulfur atoms, each will share the same number of electrons to the carbon atom, instead of one sharing a lot and the other one sharing a few. So keeping that in mind, we'll push a pair from here. It doesn't matter whether you take the one from the top or the bottom. You just need a pair from that sulfur. And by doing that second bond to the sulfur on the right, now each atom has 8 electrons. Remember, the goal here is 8. That's what Lewis figured out, is that the stable structures are the ones typically that have 8 electrons around the atom.